Well, Pharis, you just did a presentation on, I guess you'd call it alternative nuclear theory. Would that be a way to describe it?
That would probably be a fair assessment.
But this also, I mean, you have a ton of, I guess you have a ton of work that falls outside of the norm. You also have kind of a fluidics model of physics, as I understand things. And then,
Yeah, I guess I didn't think of it as fluidics, but you can apply it to fluids as well.
Well, you were telling me a few minutes ago that this all started in, I think, 1981, you said?
Well, the stuff that I presented this morning about compact reactors started then, because I had started this theoretical work before that, but I had a presentation at Los Alamos. Then Associate Director Paul Robinson asked me a question, particularly when I presented the quantization of Weil's scale factor. He asked, would that be an explanation for the quantization of electric charge? When I looked at, in response to his question, I looked for an answer. I found not only did it quantize electric charge, but a whole new model of nuclear physics came from that as well.
Okay.
And it blossomed into cosmological stuff as well as nuclear.
Yeah, and now was it because you were starting at such a base level that you were able to derive so many new, I guess, applications from it? Because you have a warp drive, I guess, that you were talking about, and then...
Well, what George is talking about is by starting at such a basic level, the scale factor is independent of the number of independent variables that you have, independent of the number of gauge potentials you have. I also have shown that Einstein's general theory is one four-dimensional hypersurface embedded into a five-dimensional space. And when you talk about five-dimensional gauge functions, the fifth-dimensional potential is the gravitational potential. So if you have a non-singular electrostatic potential, you also must have a non-singular gravitational potential.
Okay.
You also have to have an inductive tie between electromagnetic and gravitational phenomenon. Well, that argues that you can electromagnetically create gravitational forces. That's where George came up with the warp drive.
Now, so you guys actually built and tested a small version then?
I built a small, not a warp drive in the sense of a lifter, because didn't aim for that much gravitational modification, but I was able to put two cones together so as to make one cone heavier and one cone lighter and measure the amount of torque by the use of the now forgotten mercury. I had the current pass to the cones by dipping brass rods into mercury, and so the depth of the brass rods would determine the torque.
Yeah, I think John Daring had mentioned something about this, because he's a big fan of your work.
Yes, after I did that cone experiment, then John and his Tim Wren, his cohort there in Huntington Beach, made their own version. One of the problems with mine was that if you're passing large currents from a liquid to a solid conductor, you get sputtering and other stuff that people argue was possible source of the effect rather than the predicted source.
Oh, yeah.
So what they did was they put the energy source on the rotating element so as to eliminate that argument.
Okay.
And I understand they also saw positive results and put it in the EE Propulsion journal or something like that.
Now, he told me about something that, if I remember right, it kind of resembled a mushroom, the way he described it. He said it was about diverging currents, I guess, and he was talking about stretching the ether, and having it stretch more on the top than on the bottom, and that would create kind of the anti-gravity factor.
Yeah, well, of course, John was trying to create a mental picture of what was going on, and stretching the ether was probably his way of trying to visualize it. I haven't formed such a mental picture, and I don't really understand his visualization of it. What I do understand, though, is that the gravitational potential arises from a divergence or convergence, a forced divergence of electric current. For instance, where I use the cone to diverge the current, and it's a hollow cone, so all the current has to diverge. John used a disk. Now you got the maximum convergence.
Well, no. How much thrust do you think this thing produced? It was a few milligrams, maybe, or was
it wasn't that much.
Oh, okay. So
no.
It's pretty low.
In terms of torque, I forget, but it was in the micro Newton sort of
okay.
thing. But then it's limited, one, by current levels, by the divergence that you actually cause, and perhaps some other engineering factors that I haven't looked into.
Yeah. Interesting, because when he had told me about it, one of the things that I'd wondered about was how you might magnify that effect for more sizable propulsion.
Well, in terms of optimization, when I did this thing, I made cones because the fellow I had making a device for me could do cones rather easily by cutting it out of flat stock,
Okay.
But if you look at optimization, you really want an ellipsoid of rotation to maximize the effect. And I forget parameters of that ellipsoid, but to maximize the effect. It's not unlike what shapes you see of UFOs.
Yeah.
And if you make one surface at a different than the other in terms of, imagine putting current in the apex of both surfaces. One, you create heavier weight or lighter weight. So if you've got two surfaces that have opposite curvature, then you can have both lightening or taking away from the weight of the vehicle to get a lift.
Oh, okay. So it'd be kind of convex on one and concave on the other, kind of a thing?
Right.
Interesting.
In terms of looking at it from the outside, it would be.
Yeah, you've written textbooks about this, haven't you?
Not textbooks, just articles.
Oh, but
technical reports.
Yeah, well, one of the things I was wondering was, for experimenters who are out there, not just with this, but with some of the other stuff that you've worked on as well. Have you ever thought of putting together kind of the step-by-step, or kind of schematic-oriented stuff to help people along, or help them kind of build some, just prototypes to experiment with?
No, I haven't thought of doing that.
No, the reason I ask is, because the theory itself is pretty complex, but I thought that might be an entry-level way to build excitement and kind of get people involved.
You may be right there, but I spent too many years working on a day job, putting beans on the table, and this has not been paid for by my day job.
That's a good point, yeah. When you have a free time, right, you want to do stuff that...
This is hobby.
Yeah.
And the modification of gravitational stuff by electromagnetic means was high on my to-do list several years ago. There was another, matter of fact, the compact reactor, that is replacing our dependence on fossil fuel, changed my priorities. I thought it might be useful to work on a reactor concept rather than a lifter. Although I did write about some of the practical uses of George's warp drive. Can you imagine, the use of the jaws of life in an accident? Cut the person out by...
one of the things that I'd always thought also, not to sound morbid, but, on September 11th, because the air currents and stuff around those buildings, I almost felt like even if they'd had the helicopters ready, they would have ended up crashing them because of the turbulence. And
almost everything you put there would have had a terrible drag on it.
But if you have a, gravity-based craft, part of it is hopefully it would be a little bit less susceptible to the aerodynamics and the other...
Well, certainly your lift wouldn't be susceptible to the wind velocity, but the drag on the vehicle would be.
Yeah, I'd also thought that it would be, by not having the fins and rotors and stuff, right? You'd be a little bit more safe working in close proximity. Yeah. Or even, commuter transportation, right? You've got power lines and trees and stuff like that, and so there's definite applications there.
Let me go back to your textbook and telling people how to do it, and this notion I was talking about with draws of life, because one of the practical applications that I did write about was an emergency lifter. Suppose your fire truck, in addition to its jaws of life, had one that had this thing and powered it by a generator. You could pick a car up off of a trapped person. the old sky hook, if you will.
Yeah. Well, let me ask you about the compact reactor, because now when you were describing this, you'd said that this would run for hundreds of millions of years. Would that?
Yes. Yeah. Well, what I did was I looked at a 50% fuel loading that I did the calculations, and I said, how long would it take to diminish that 50% down to 40%? It'd still be a very useful reactor. That was 310 million years.
And essentially, the parameters for maybe, I mean, you're thinking that you could put a 10 kilowatt generator, using this technology on the side of a person's house that might be 1 square meter in size, right? 1 cubic meter.
Right. I doubt that you need 10 kilowatts continuous power to run a household. Probably a quarter of a meter would be sufficient, because the best system I could see is use a continuous power source to maintain the charge on a bank of batteries, and then use inverters for your AC and DC lights like a current RV does. And
this is just a small amount of metal hydride that this is burning, right, for fusion?
Well, no. The quarter cubic meter is that of the metal hydride. That's the volume of the metal hydride.
Okay.
So it's not a thin.
Yeah.
I mean, the engineering application of it might have it in thin sheets. For instance, you might sandwich a thin sheet of this between two thermoelectric diodes or that sort of stuff for the engineering aspect of it, but you would need a quarter cubic meter of volume of the metallic hydride.
Okay, and so the metal hydrides, then, that's for the fusion, that's your fusion fuel, right?
That's correct.
Yeah. And it's an interesting idea. Now, the prototype, you said, would be less than 500 thou, but I mean, so do you think this could be cost effectively produced for the house, though, in a manufacturing setting?
Absolutely. Well, I say absolutely. I say that with an ignorance of the cost of thermoelectric diodes, but if you were to look at a lifetime of a house of 20 to 40 years, and there'd be no need for utility bills, at least electrical utility bills, in that lifetime, how much could a person spend then on a reactor?
Well, but this would generate neutrons, right? So you have to have...
That's the beauty of it.
Be aneutron, okay.
Yeah. Perhaps I didn't specify it, but one of the things that I sought was a totally non-radiative action. There's no radiation before, during, or after the reactions.
Okay, so it's clean.
It's totally clean. That was the attractiveness of it, was that cleanness, because what good is a home reactor if you have to worry about shielding it?
Yeah. Well, now, have you had any bites yet in terms of potential funders to work on it? But potentially speaking.
Potentially speaking, yeah. My friend George Bates and I are going to respond to a naval research, perhaps it's ONR, BAA. They're asking for a source of energy and whatnot.
Well, and I think it's good to look at technologies like this compared to, it seems like the large mainstream interests are still pushing solar and wind and the stuff that's proven itself to not be the best, And I guess they can get the job done, but I mean, Scientific American keeps putting out these charts saying that, if we, even with breakthroughs in solar and wind, we'll still need to spend a bunch of money on infrastructure and,
Yeah, plus I think there's variables there, depending, like, of course, the such stuff as the windmills depend upon weather.
Yeah.
And this compact reactor depends upon nothing once you put it in place, except the magnetic field.
And this provides a path forward, too, for higher levels of power in the future. I mean, when you think about how much the average person consumes now compared to, 20 or 50 years ago in terms of electricity, and a lot of the projections for these solar wind hybrid systems, that I keep reading about are really based on current levels, assuming larger population. So it's a growth of energy, but based on population and not necessarily usage.
Yeah.
But I mean, we live in an era where everything has computers in it now, and just little things like that just draw energy left and right. So.
Right. Even though small, it adds up.
Yeah, and this would give us kind of a scalability to move forward and say, okay, well, here's where we're starting.
Right.
There's a little bit more legroom, I guess.
And I can easily see power stations. All you have to do is have a stack of metal hydrides. Well, I say metal hydrides, and it doesn't have to be metal. Okay. All you need is a crystalline structure. The reason I use metal hydrides is that because of all of the work done in metal hydrides for storage of hydrogen for fuel cells. Because you can store more hydrogen sticking it in a metal lattice than you can trying to compress it and make liquid hydrogen.
Oh, okay.
Okay, so that's the reason I said metal hydrides.
Yeah.
A non-metallic might even work better.
Now you have paper. I mean, you obviously have the STAFE paper, but you've also written other papers on these
On
generations.
this particular concept, I did not include any verbiage on this application. I have papers in the open literature on the fundamental theoretical stuff,
Okay.
but I left out applications.
Well, now I guess one of the places that people can find this is on your website, right? And
Yes.
could you list your URL for us?
Pardon me?
Oh, your URL, the website.
It's www.edu, NMT for New Mexico Tech, .edu/Pharis.
Oh, okay.
Okay, and that has my 1993 book, which has the warp drive, if you will, and both calculations and the discussion of the application.
Yeah, I visited your website a while ago. It was a little bit like drinking from the fire hose because there was so much information.
Yeah.
It was, where do you start?
You got to remember, I've been at this for 30-some years.
Yeah, but I mean, I think that really speaks. You have the level of respect that like that John giving your work. I mean, he was almost bowing down, and
Oh, I see.
so I think that that really speaks to how much work you've put into it.
Well, I think that speaks more to the logical consistency of what I've done, stemming from theoretical fundamentals that is well accepted, and throw in no ad hoc hypothesis.
Well, do you think that our society is ready for these kinds of technologies? The reason I ask that is it seems like America is almost of two minds on the issue. We're really comfortable with what we have, although we know it has limits. We know that we're reaching the end of those limits, but it's always that when is the paradigm actually going to shift? And I'm wondering if you feel like because I feel like the STAFE 2007 conference, what I'm seeing here at this conference is building upon what happened at STAFE 2006. And you're seeing things like gravity modification being used in AIP published, journal published papers. And it's really kind of a big first for that,
That may be. The human nature is such that we do like well broken in shoes rather than something new that we don't know. And it's difficult for the human mind to visualize something new. For instance, I gave a talk years ago, and a fellow came up afterwards and said, "I've got to give you an article I wrote, not for its technical content, but for its soapbox at the front."
Okay.
And in that soapbox, he said that there were three kinds of scientists. One he called innovators, and they were the ones who could see something that never had been seen before. That was about 1/10 or 100% of all scientists. One group he called testers. They were the ones that once the innovator told him what was going on, he could see and determine a method of testing that concept. And all the rest, and there's probably maybe 5% total scientists could be testers. All the rest, that is roughly 95%, are keepers of the flame. They could say what they had heard before, but they couldn't see anything new, and they couldn't devise a way of testing something new.
Because they work for the government, right?
Perhaps. Perhaps.
No, I probably shouldn't say that too loud at this conference.
Yeah, I understand the source of that because I've interacted with government my whole.
I think that it swings back and forth though, and strangely enough, some of the most innovative ideas are coming from within the government. And, government engineers these days. So.
Well, there's a human trait with innovation too, and you have to have someone new to a field to really have an innovative idea. And a lot of the people in government who were there at World War II or shortly thereafter are now retiring. So you get young people in some jobs, and perhaps the innovative ideas come from those young people.
Yeah, also some of the ideas, a lot of the older people who are retiring feel like they can now open up about some of the stuff they've been carrying around, for years.
There's another side of that. I spoke earlier about this wasn't my day job. And in earlier years, as a naval officer, where people don't perceive naval officers as being scientists, they're ship drivers. So I wasn't given credence to be a scientist, but it paid the bills.
Yeah.
If one tried to get a job as a theoretical physicist doing what I did, one would never have a job because you have to kowtow to the current paradigm in order to be hired in physics. So to me, it was a blessing not to be working on this at my day job because I could free to think my thoughts and no one could direct how I went.
Yeah, absolutely.
If you're working for someone, even to the point of a student having a thesis advisor, you got to do what he says. So they really ought to remove the words original research from the doctoral.
I see what you mean. Because in a sense, it almost is keeper of the flame stuff. It's indoctrination.
Absolutely. As a matter of fact, I don't have a doctorate just for that reason. I was teaching at the Naval Academy. I went to the University of Maryland. Let me back up. When I was in Monterey at Naval Postgraduate School, I was in a doctoral program, but I failed to pass the French, so I couldn't get my doctorate.
You said the French?
The foreign language.
Okay. Because back then they were teaching.
Right.
My mom learned that in school, but anymore they don't.
Well, when I was teaching at the Naval Academy, I went over to the University of Maryland. They said, we don't have a language requirement. Come and. And they said, you got all the courses. All you need to do is to take 6 hours to establish residency and talk with one of our professors and get your dissertation topic going. I said, okay, I'd like to talk to these 3 guys who I'd known was doing the sort of stuff I wanted to do. He said, wait a minute. We here know we owe the incoming student a research topic, but it doesn't have to be one of their own choosing.
Yeah.
And I stood up and I said, I don't think we have anything more to talk about because if I have no say in what I do, I'm out of here. So it is keepers of the flame sort of stuff.
Yeah.
And that's why there's no more publications of mine out there, is because the peer review is set up as keepers of the flame.